Welcome to DWBIADDA channel. Please subscribe for latest training videos.
Hello everyone, welcome back to the tutorials on computer vision. The last lecture on mini project, we were at the point where we have actually detected the edges of the car, and now we want to detect the contours and then the shape of the number plate. So without wasting much of your time, let's get started on this. What I will do is I will go up and fire up my Jupyter notebook. So this is where we actually left, and now I want to detect the contours from the image. So for detecting the contours from an image, what I'm required to do is I'm required to call in two variables cnt and the underscore one, because I don't need the underscore variable as of now, and then I will actually use cv2 dot find contours, which will actually find all the contours for me. So find contours, and here I am required to pass in the argument, which is the edges, and then cv2 dot red tree get tree, and then cv2 dot chain approx none. Like these were the one we were actually using it in our next last lecture as well, uh, like this. And now I've actually find out the contours in a region, like in the whole car. And now once the contours have been found, what I required is that these contours I mean, because there are a lot of contours that can be detected in a car, like the windows, like the headlights, and maybe the uh, bonnets and something like that. So what I want is that these contours should be actually sorted in the descending order of their area, and the one with length 4 should actually be my result, because the number plate is actually a rectangle with a length 4, and because there will be 4 points that will be connecting all the rectangles, and therefore the length is actually 4. So what I will do is I will go ahead and write cnt is equals to sorted. In sorted, I will pass in the cnt, like this is what we actually require to sort, and then I will pass in key is equals to cv2 dot contours, um, contour area, actually not contours, so contour area, and then um, reverse is equals to true, because I need that in descending order, and I will found out the first 30, like the largest 30 in areas. So once this is done, I will run this piece of code as well, and now what I will do is I will actually iterate through every contours that have been found and find out the one which is of like a rectangle length, and the length is actually of 4. So what I will do is I will iterate over the contours for I in cnt. In contours, this is how we actually iterate over a list in Python. What I will do is I will use one function which is known as cv2.arcLength. This arc length will actually get like what the length of an arc is. Like that can be a line segment, that can be a circle. The length of the arc, like as it is very clear from the name. And I will pass in the method, I mean the contour, the current contour over here, and then I will pass it true, because ours is a closed contour, because we want a closed contour actually. And I will write peri is equals to this, because this is the perimeter, or maybe like we are storing this in a variable known as perimeter. And not now what I will do is I will go ahead and create another variable which is known as approx, and I will use another function which is known as approx polydp. So this approx polydp actually like filters out the shape that you actually require. So let's say you want the shape rectangle, which will be actually done by connecting 4 points, that is on the 4 edges. So this is where we actually get a rectangle or a square. So this approx polydp function is actually used to like detect shapes from an image in OpenCV. So approx polydp, and here I will pass in the current one I'm in, the current contour I am in, and then how much accuracy till you require. So I require up to an accuracy of 1%, and I will pass in the peri over here, and then true, because true because it's a closed contour. So once this is done, I mean once the approx method is done, what I will do is now if the length of approx method is actually 4, because if the length of approx method is 4, then that means we have got our license plate. I will go ahead and I will store this in a variable known as screen count. That is approx will actually return me all of the coordinates. So I will go ahead and store this in a variable known as sct, and I will break it over here, right? And I will run this piece of code, and as you can see, it actually successfully ran. And what happened is that now I will check out what my sct actually is. So my sct is actually these 4 points. So now I will go ahead and check if these sct is what I am looking for or not. So this is how, I will actually use the draw contours over here, because this is a contour for me. So I will store this in a table, let us say q, and cv2 dot find contours, find contour, sorry, dot draw contours, actually not find contours, draw contours, and here I will pass in the image, on which where we try to draw the contours, which is img, and then I will pass in the contours itself, which is sct, and then I will pass in, like, I require only the 0th or the one I am currently at, and then the color like 0,255,255, and let's say the thickness is 10. I will go ahead and run this piece of code, and as you can see, it successfully ran, and now I will see you what it actually looks like, or whether it has actually detected the contour or not. So replace it with Q, and this is the result that I actually get. So as you can see, this has actually detected the contour for me. So once the contour has been detected, what I can do is, I have the points which are X, Y, W, and H. I can actually draw up a mask over here. And in this mask, what I can do is, like, everything except this will be visible, and this is what our region of interest will look like. So I will end this lecture over here, because we have learned quite a few things in this lecture, like using the arc length, which will actually find out the length of the arc, and approx polar dp function, which will find out the different shapes, and a lot more stuff over here. So it has gotten quite complicated, I guess, and you need to revise this till now. So I hope, like, you enjoyed this lecture and you learned something interesting and important from it.